And so like this is what we call a script. If you want to make a function, you say function here. You say what it should return. It should return maybe like the only thing that we create in here, so it should return A. And this is called, it should always be named the same as the script or the file's name is, so it has to be hello world, okay? And does it need a parameter? Maybe it does. Let's make it need a parameter. We say this is our input parameter. So we say it needs this, and then now this is our function here. So let's open the, where is it? This thing here. So now we have the hello world script here, and we can say hello world, and it will break because we didn't give it the input argument. So now we need to give it an input argument. Let's say it's 5. Then it returns something, which is this part it returns here. But we can also say it shouldn't like just display it. We want to have it here, so we do it this way. And then we have A here, which is basically 5 random numbers. Okay? So this is how you do functions in Matlab. So other interesting or important stuff that we need in Matlab is we need if clauses, for example. So let's say we want to only get like one random number, and say if A is greater than 0.5, then we say we display greater, and else we say smaller or equal. Okay, and then we close it like this. So if I now run this section here, the whole thing, okay, I ran the whole thing, was smaller or equal. Oh, bummer, let's run it again. Yeah, now it was greater. Okay, so this is kind of like how you do if clauses. You can do for loops as well as while loops or whatever. So you can say for I equals 1 to 10, display I end. Okay, so what's going to happen here? It will just run through this 10 times and print out something every time. Okay, it's very easy. So for loops are very simple to do. The fun thing is, I think you might be able to define functions within a script. Okay, no, you're not. It needs to be a function as well. I usually never do that. Nothing, it's fine. So the interesting part is that if you define a function within a function outside, you cannot call this function. It's not defined, okay? So that's kind of like one interesting part here. But let's get you guys prepared for the homework assignment. So Matlab's really like just play around with this course. Like, you know, there's a lot of functionality. I think plotting, we had that last week, and matrix multiplications, for loops, if loops, functions, etc. This is all kind of like more or less intuitive and the same for other languages. But really, Matlab is nice because you can inspect everything. I can look at my workspace. I can check out my variables. I can plot stuff. And I can, I have a really nice debugger as well. So I can go step by step through my code. Did I show you the debugger? Maybe not, right? Why did it not like this? Oh, and is missing, okay. So we can set a breakpoint at any point and say, okay, run, and now it stops here. And I can say step, step, step. I can check my workspace at every single step. So this is really cool. If you don't want to set a breakpoint here, you can say break, and it would always break here. No, what was it called? Keyboard, sorry. Keyboard, and it would always break there. And now you are here. The little icon indicates that you're there. Again, you can do step, 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 etc. So that's kind of cool, that you have really a lot of control about your code. You can also, if you want to see the code before something happens, it's just like, okay, I want to pause, so now it's pausing, you see? Paused, press any key. Where's the any key? So then it goes on. Alright, so let's do a little bit of the Matlab classification stuff. So we had doc and help. So let's do the look for classify. We want to classify something. KNN classify, SVM classify. What is that? CV sequential FS demo. That's a feature selection demo. But you see there are like KNN classify, K nearest neighbor classification, classify function, and SVM classification. So there are different types of classifiers already in Matlab. So we can click on this guy here to get some information about what's going on. This is a discriminant classifier. Okay, interesting. Here's some inputs, some variables, etc. Let's look at the documentation of this. So I can type doc classify here, or I can also just press it here. That's the same result. So anyway, so I get this here. You can read all the descriptions here and really read the descriptions. They're very, very helpful. And so now I can look at the examples, and guess what? There is the Fisher Iris example. So the example that we had, and these are always the code samples. This is always the comment about this. So I can take this and copy it, paste it down here, and we have the output. So what you see already is the red ones and the blue ones are not easily separable with just a line through. But we have more than just two features. So in this case we have sepal width and sepal length. So SW and SL. But really we have four features, right? So these are our four features here. They are also described somewhere. Is it here? Oh, these are the labels. Species and groups, versicolor and virginica. I don't actually know where the explanation for the features are. Is it mentioned somewhere? That doesn't really matter. So anyway, so we have four different types of features. These are our measures, 1, 2, 3, and 4. And based off of these four features, we want to classify the different types of iris flowers. So this is, we can plot it in 2 dimensions. There are multiple other dimensions that we could also look at. So what's happening here is we select the first feature and the second feature for two groups, two classes. We give it so the group names are the different the targets, or like our these are the labels that we want to look at, or that we want to classify. This is just plotting what we have here, and then so we can classify that. What does it say? Classify a grid of measures. So we can create the mesh grid that like creates something visual. I think what is the X and Y? So yeah, these are just a mesh. I don't really need that. And then we can make this a linear version, and now we call the function classify. We want to know C, which is I think the confusion matrix. This is the error. P is something else. What is this? So C is the class. Then P is the prior. ERR is the error, and so this is all explained in here. Posterior is the posterior probability. Log P is the logarithm of probability, and these are the coefficients that we learned. So I can throw this here and say I want to see the output of this. So where is it? We need to plot it now. So now we draw it nicely here. And so this is our output, this is what it learns. So you can see this is a quadratic function. This is because we told it to be quadratic. We don't have to do that, we can say linear here. If we don't say anything, I think it is linear in the so this is the type. I think by default it is linear. Where do we have to type? So it says here type, and then for linear, diagonal, or quadratic. So these are the three types that we can have. Where do we set it? Oh, here. So this is here. So we say linear, diagonal. So this is like a diagonal, a quadratic, diquadratic, or Malanobis. We can classify it in different ways. So let's look at our outputs. So what's the error? It's 2.9, so that's mediocre, not really great. Let's see what happens if we say we want this to be linear. This is the error linear, and we don't need the other outputs here. So what do you guys think will happen? This is our problem here. So now we just learned this separation here. Just like a nice curve going around most of the red ones. A few red ones are in here, a few blue ones in here. So if I need to learn like a line, a linear function like this or like that, you think now that we have less expressivity, is it going to be more accurate, less accurate? Less accurate, probably. Let's see. It's actually better. It's kind of funny. We can run this again and see how robust it is. Is it going to learn always the same thing? In this case it does, because the classifier here is not dependent on any initialization. So this is when we classify, what was it? In this case it was the Virginica versus versicolor. We can like take others, so we can take the species here and say, so I have the first 50 are setosa, right? And then it's versicolor until here, and then it's virginica until 150, right? So let's say we want to classify the other two. So I think it will be easier if we put it into a nice script here, just to make the difference clear. So we do this, then we take this, and then we do this. I'm not sure if this is going to work out because parameters might be different, but let's just try it out. So now we need from 1 to 100 and not from 51 to 100. So now we compare setosa with versicolor. What else do I need to do? I think that is already it. So we're going to be setosa versus versicolor. Alright, oops. Yeah, so it wants to save it, so let's say Fisher classify. Oh, whatever. So let's run this whole thing, see what's happening. Okay, I should probably clear all, make it clean, see what's happening. So now I learn something that's separating them almost perfectly. This is like a little bit of an error here, and the separation is much easier, and we didn't really need a quadratic function either, so we could even actually say linear here, but then this probably doesn't work because there's not going to be two parameters. Yeah, they're not two parameters, but yeah, we can run this and the error is very small, as you can see. With quadratic it's very small too. It's also the same arrow, okay? So this is kind of like the classify function. And so now what we've discussed today, that having error measures and like class predictions, etc. Oh, that's actually pretty cool. Just realized that we can also, yeah, so we can probably do, let me see if I can find a confusion matrix. Ah, here. Now this is how you use the, like, because there's a lot of stuff already done in Matlab that you don't need to develop again yourself. And again, hey, here's the Fisher Iris sample for how to use a confusion matrix. So now you can make a confusion matrix with this as well. Okay, and then this is how you how the output of the confusion matrix looks like. But we can already do this. So we can say. Oh, because it has run this so many times. So let's just run it this way here. So I do this again, and then I can try this out. And again, it uses the classify one here. And in the end, I can print out my confusion matrix, which is nice, and my 3 classes that I can learn here. So based on this confusion matrix, you should also be able to calculate F1 measure or precision recall that we discussed today. Okay? And they're almost perfect, as you can see. Like, there's not going to be very interesting observations here. Okay, so this is like how you use classify as a function and confusion matrix, and you like it reports some errors, it reports some additional information that you can use. But really the important part is the error and the confusion matrix. In the classify one, you can use different types of classifiers. You can say linear, quadratic, etc. But now, in this case, it runs it once, right? And it uses, or it splits the data in some way that we cannot control into test and training set. But we want to really control this. So there are functions in Matlab that allow us to control this. So one function here is CV partition. So CV stands for cross-validation, and then CV partition, cross-validation partition. And so the function is here. Now I can define if I want a k-fold, that could be 10-fold, 4-fold, 3-fold, whatever. I can say I want holdout, I want 20% of my data for testing and 80% for training. Okay? I can do leave out, so that leaves one out and trains on the other and then rotates through. Okay? And I can use all these, and yes, we have another example of Fisher iris to use this. Okay? And then there's a function cross-val. You could look into that as well if you want to use this. So I think you already see there's like kind of this pattern of using the inbuilt functions of Matlab for machine learning experiments. And what I really want you guys to do for this week is look into the machine learning specific functions that are available in Matlab and try to run a simple machine learning experiment with the Fisher iris dataset or any other dataset that you guys want to like use. You know, you can use another simple dataset that you find, but I would suggest just use the simple dataset that's here. You know how it looks like, you know the features, how they look like, and you know that the result should be more or less good because it's very easy to separate those. So that's kind of the idea for this week. I would really not like to see that you used exactly the same feature names or exactly, you know, the same variable names, etc. Because then I know that you didn't try it, you just copied it. But just, you know, like, don't cheat yourself. Try to maybe put a creative twist on it. Maybe you can actually separate it out into training, validation set, and test set, as we discussed earlier today. Because cross-validation and CV partition doesn't do that for you. You have to do that one manually. So you could use a validation set to find out if linear or quadratic is best, and so on. Or you can do KNN classify or SVM classify. Just try out, see what's there, use the search function, and that's it. Thank you, and see you next week.